Hello, Scholar Practitioner Leaders, SPLs, Data Scientists. Welcome to our week 6. And I want to congratulate everyone for the tremendous job that each and every one of my SPLs have done from this past week 5. It looks as though that all the grading and all you guys' due diligence on your 2 assignments from week 5 paid off very, very well because your grading looks really, really solid. Well, I shouldn't say actually grading. I would say me doing my cursory checks because during the week I've been looking to see where you guys are at, and each of the assignments that I look at, and there was 2 assignments from this past week 5. And when I look and I do the review and I do the checks against my directions and the rubric, it looks like you guys are really, really aligned concisely. So great job, everyone, with this week 5. But I want to welcome you to this week 6 again. And this is for our 2025 fall statistics for data science, MSDS 531 A01. And this is for our second, or better yet, it's our first buy term. So, with that being said, guys, I want to go ahead and look at our week 5 because, like I said, you guys did very well. I don't think I had any emails or phone calls in regard to last week's assignment. So I'm feeling really good, and I'm actually really feeling good about the way that I'm presenting the material to you. Because when I don't get a lot of questions and or emails, that lets me know that everything is truly coming across concisely in regard to you being able to exude what I'm looking for on your assignments, thus getting the outputs that we're needing to show me that you're actually understanding the material, and you also getting a good lay of the land when it comes to statistics in our course. Okay, so good job, everybody. So with that now being articulated to you guys, let's go ahead and look at the outputs, or let's look at what we did and what we discussed last week before we jump into this week 6 material. Because I really want to go back and just, as always, I like to try to maybe just look at the things that I talked about, and also to see if what I presented to you guys was exactly what you saw in the assignments that was due for the past week or that current week. So let's go back, as always. Let's look at our assignment from this past week 5 and just see if Dr. Mark was actually aligned to getting the outputs that I needed from you guys. And like I said, it looks like I was, because your assignments are very, very strongly aligned to what I spoke on in the lecture last week. Okay. So, with that being said, we're going to go ahead and talk about our deliverables from the week 5 before we get into, again, this current week 6. So let's look at my overview that I discussed with you guys. And as I just mentioned, that is the deliverable. And as you look on the announcement board, you actually saw that deliverable, which is derived from the overview. Okay. All righty. So for week 5, I outlined to you guys in an eloquently manner that data scientists are tasked with classification problems. Okay. That's what I had mentioned last week. And I said a form of supervised learning in which we first train a model on the data where the outcome is known and then apply the modal. Okay. Well, some people say modal. I like to actually say model. To apply the model to data where the outcome is not known. So then I mentioned to you also, often we want to know the predicted probability that a case belongs to a class, okay? Rather than having that model simply assign a binary classification that I had mentioned last week. Most algorithms can return a probability score, which I stated is actually the propensity. So I hope you guys got a good understanding of what propensity is from this past week 5. And then also of belonging to the class of interest. Classification is perhaps the most important form of prediction, as you guys have now seen. It is a common predictive modeling to train a number of different models, apply each to the handout and or holdout sample, and assess their performance. Okay, so that was crucial. When you looked at week 5, you actually saw that in those 2 assignments, and I'm going to discuss those shortly. Those assignments that we actually went over in the next segment that we actually talked about last week, and you actually uh, executed. And like I said, you're scoring. The actual cursory review from my sample checking of your work looks really, really promising. So I'm really looking forward to grading those 2 assignments this week. So after a number of models have been evaluated and turned, and if there is enough data, the third holdout sample not used previously is used to actually estimate, as you guys saw, how the chosen model will perform with completely new data, as you guys came very, very abreast to from this past week. Fundamentally, the assessment process attempts to learn which model produces the most accurate and useful predictions. So, week 5, everything I just articulated, which is again the deliverables, you saw that. So, I'm hoping from my deliverables from this overview, you have now put that in your hip pocket. You understand it. And like I said, from my cursory check, it looks like each and every one of you guys do. But I'm really keeping my fingers crossed so when I grade your assignments this week, I actually saw where you actually understand how once the models have been evaluated and tuned, and if there's enough data, then the third holdout sample, not previously used, is actually used to estimate how the chosen model will be performed with completely new data that you guys had. Okay, so I'm really looking forward to that. And then, as I just stated, fundamentally, the assessment process actually attempts to learn which model produces the most accurate, truly the most accurate and useful predictions. Okay, so when I grade your assignments, I'm keeping my fingers crossed. But like I said, me already doing the cursory checks, it looks like you guys are truly, truly understanding the predictions and how it can be useful as you do your assessment. So you guys are all over it when it comes to classification problems. Okay, so based on the lecture that I gave you for week 5, so my lecture was very indicative of what I just spoke on in those actual deliverables. Okay, so you remember that I stated you're going to have seven module objectives by the end of the week, and you actually did. So you had to calculate those probabilities with naive Bayes method. Okay, the NBM or naive Bayes method. Okay. Secondly, you had to perform that discriminant analysis that I spoke on last week. Then you had to describe that old logistics regression. You got to know it. So I'm pretty sure, based on the way that I talked about logistic regression, that you guys understand how to differentiate those various types. Okay. Because this week you had to focus, well, this past week, you had to focus on the actual logistics regression once again. Then, fourthly, you had to describe strategies for dealing with the imbalanced data. Okay. And you guys should know now what exactly is imbalanced data based on the chapters reading. Okay. Because I spoke on it last week. Okay. So then, fifthly, you had to explain how generalized linear models work. And then, number 6 of 7, you had to use the actual logistics regression model appropriately. Okay. You had to show me that you actually understand it and how to apply it. And then lastly, as always, I wanted you to actually differentiate between generalized linear models and the Poisson models. Okay. And then ultimately from week 5, as you can saw, you had to read, based on what I told you, the practical Statistics for Data Science, our favorite book, our electronic book, you had to read from chapter 5, the classification section. That section had 5 areas that I spoke on. And as you can see, as you saw, actually, you like, okay, wow, Dr. Mark, he outlined it pretty good because the chapter is truly granular, and the actual authors, the 3 authors, actually break it down. Bruce, and Geddick actually break it down very granular, as Dr. Mark, hopefully you guys was thinking this, the way that he spoke on it. So you had to read that chapter 5 and really, really get a good lay of the land. And that's what it's all about, making sure that you understood how to diversify classification. Okay. It was 5 areas. It was Nays, Bayes that I just spoke on, discriminant analysis that I stated last week, logistic regression again. As long as you understand, because that's typically the primary regression that we use a lot, but you had to still understand those other 6 that I spoke on in the previous weeks. Actually, it was last week, okay? And then how you evaluate, well, it's actually week 4, but it was also in this past week 5, as you saw, logistic regression. And then you had to understand how to evaluate classification models. What's the premise behind that? And then last but not least, the 5th item from chapter 5, classification, that section was making sure, as I spoke on last week, that you understood the foundations of strategies for the imbalanced data. Okay. So you guys should really have a good lay of the land on what imbalanced data is. Same thing with the evaluation of those classification models, making sure that you truly understand Nave's Bayes actual what that's all about, because Naves Bayes guys, we're seeing that a lot now as we move forward through our course, our statistics course. And then that discriminant analysis piece, and we all know about the therefore mentioned regression, uh, logistic regression model. Okay, so that's huge, guys. And like I said, from me looking at your work, it's looking really good. That's why I said I cannot wait to actually grade your assignments, and I have them to you by week's end, of course. More likely Saturday, the usual. But yeah, those 2 assignments, guys, was really, really solid assignments. You had your discussion posts. We all know those are worth 20 points, and then we had the actual assignment that was due. And I'm going to speak on that the next lecture. Okay, and then also from week 5. We had to read section 8 in our modern statistics with our embedded link here in our content. Okay, that electronic book that's part of our weekly assignment that's in the actual assignment. So you had to look at those 8 regression, section 8, excuse me, regression model, not 8. There's only actually 4 areas that I want you to look at in chapter 8, okay, or section 8. But those 4 areas was really indicative of what the author was talking about when you're talking about those regression models, okay? Because 8.1, as I mentioned, I told you last week in my lecture, make sure that you understand linear models. And this is all carryover really from week 4. So it shouldn't been anything that you didn't really understand. That's the reason why I didn't get any emails or actual phone calls during my office hours, of course. So that's really good, guys. So kudos. Less work on my end is always good because I feel like, hey, everything that I'm articulating to you guys are really appreciating the way that I'm breaking the assignments down for you guys. To make it, again, just like the author makes it granular, I want to do the exact same thing. Okay, so 8.1 again was the linear models. Then 8.2 was the ethical issues in regression modeling. Okay, I had spoke on that last week. Same thing with 8.3 was generalized linear models. That's what it was all about this past week, week 5. And then there's section 8.4 that I wanted you to look at, the mixed models. So that was it from our embedded book from the link. And once you did that, you should have been good to go as far as your assignments. And then you always had that supplemental book material that I always give you guys if you want to do a little bit more deep diving on the type of content that we're talking about or going over for that respective week, which in this case was week 5. Okay, guys, so that was it for week 5 for the most part, your learning materials. Now, when I come back, we're going to actually go over our week 5 2 assignments, okay, because those was great assignments, and we're going to do a deep dive on those. So I'll see you in just a few seconds when we come back for our lecture 2 of 4 for week 6.